Hi, my name is Murthy Upmaka. I'm a field solutions engineer for Keysight Technologies. In this video and few other future videos, I will discuss some fundamental features in SystemVue that will help you achieve more advanced phased array architectures. If we want to model an antenna, there are two things that we need to collect. Number one is the element patterns of the elements as they are present in the presence of other elements. This is what we call embedded element patterns. And the S matrix of this array. If it is a finite array, if it is within the limits of the electromagnetic tool, we can capture the entire S parameter array. Otherwise, we may have to resort to other techniques to be able to scale up the S parameter file to a large number of array, uh, to a larger array. It's very important that the way we model this antenna array in the electromagnetic tool, or as it existed in the hardware, as we measured in the anechoic chamber, we have to bring the geometry as is into the simulation tool to be able to build a very accurate model. Another aspect is antenna arrays are no more very simplistic rectangular arrays as shown here. There are very novel architectures that are out there where the elements may not be as uniformly rectangularly or square geometries described here. Now, EM tools, most of the EM tools, including the EM tools from Keysight technologies such as EM Pro, RF Pro, and Momentum, allow us to simulate the array and capture the pattern files either individually or in one file. The file is called with an extension .ff50 in the case of EM Pro and RF Pro. In the case of other tools like the HFSS from ANSYS um, or from CST, it is possible to capture all these files as a function of frequency into one single file with extensions like FFD in the case of HFSS. As we capture these files, or as these files are captured into one single file, they go by the ports that are placed on the array. For example, the ports placed here are 1, 2, 3, 4 in this order. These are placed row-wise. So how can we go take this array and then map it in SystemVue? If we go into SystemVue and then if we just use the architecture, say we define a 4x4 array, rectangular 4x4 array, SystemVue has a default way of placing the elements in this kind of a fashion. For example, if we leave it to the tool, it will place element number 1 at the bottom left corner, element number 2 going up, and then it goes, consumes all the rows and comes down again and then go to the next column. So it will number the elements in this fashion. Then if we point the element patterns that are there in our disk, hard disk, they will be pointed like this. So this file that we remember, this file was collected with an antenna that was at the top left corner, not at the top bottom corner. So if we leave it to the default behavior of SystemVue, we will not be describing the array geometry as it was in the electromagnetic tool. So this is not exactly what we want. What we want is to be able to describe that our element number 1 with port P1 is at the top left, going in a row fashion, coming down, and then going in the second row, etc. So what we have to do is we have to do a custom configuration here. A custom configuration is nothing but describing the location of the elements using their coordinates. We are showing only x1 and y, x and y coordinates here because this is planar. All the z coordinates are 0. So first thing is to generate the coordinates of all the elements as they were in the electromagnetic tool and group them into arrays, X array and Y array, describing X1, X2, X3, etc., Y1, Y2, Y3, etc. Then the pattern files will be mapped as shown here. What it will do is it will go to the element with the coordinate, with the first coordinate, will be mapped to the first file in the set of files that we collected. Or this will refer to the first pattern file if all the files are in one single file like .ffio, the first pattern file will correspond to the first coordinate, second file to the second coordinate, etc. So now you see we have no ambiguity between the pattern files that are there collected from the electromagnetic tool and how they are mapped in SystemVue. This is very fundamental, and then this can get even more complex as we see later on. Let's say if it is if this array is not simply rectangular, if it is a hexagonal or it is circular, or it can be even three-dimensional array. So we always should go by the coordinates, and we should remember how the files were collected from the simulation from electromagnetic tool, or they were collected in the anechoic chamber. So let us say we mapped even rather more differently, placing the first coordinate here, placing the second coordinate somewhere else, the third coordinate somewhere else, etc. If we randomly, not random, but because of some considerations, the array designer has placed the ports as shown here. So how do we map in that case? We map them in that case by, again, describing our coordinates and then putting the coordinates as shown here. So the coordinate, the first coordinate will always correspond to element number 1. So this will become element number 1, element number 2, element number 3, 4, etc., element number 16 here. So the pattern files now, how will they go? The pattern files naturally follow. The first pattern file will go to the first element, which is placed at the coordinate x1, y1, z1, x2, y2, z2 will be the second pattern file, etc. So there is again no ambiguity. This will give you very easy way of placing the elements at the desired locations. Now, in SystemVue, when you place them, you just specify the coordinates. But how do you know where is what? So there is what we call phased array visualizer is available in SystemVue. For example, if you go to SystemVue and the antenna is here, we let's say we go and then select custom mapping here, and the coordinates are entered, and it's a 4x4 array, but it is entered here. But we want to see how the numbering is taking place. So here you can come and then add what we call phased array visualizer. And then if you click on that, it will come up and then show you exactly how the elements are placed. For example, in this particular mapping, element number 1 is here, 2 is somewhere else, 3 is some other place, and 4 is some other place, etc. So this is as per the desired geometry in the originally where the element patterns were coming from. Let's go back to our PowerPoint. So the phased array visualizer is a very useful tool for you to be able to achieve the pattern that you want to. Now, the question may be, what about the S parameters? It's so easy, the S parameters will follow the port numbers. So the the S11 will be here because the first coordinate, the port P1 is here, S11 will be here, S16 will be the third on the top row. So they just naturally follow. So we have not much ambiguity left if we want to uh, think of S parameter assignment to these pattern files. Now there is a host of um, help documentation where you can read the required file formats, how SystemVue reads them in defining the phased array antenna. Well, within this short video, you have seen how we can custom map and then remove any ambiguity. And we can also see how to visualize the numbering that we put on the custom map. In the next video, we will see what happens, how the signals flow from the antenna as they flow into the electronics, how the combining happens, how does the electronics know which signal is which channel. That part we will talk in the next video. Thank you very much for watching this video.